Before we moving into the solutions under conditional probability, let us know what conditional probability is. Conditional probability is actually probability finding the probability of some experiments under the other conditions. Okay, so there is a probability should be obtained whenever another condition is also applied on this probability. And the fundamental formula for conditional probability is, suppose probability of A given that B, and the formula is probability of A intersection B over, that means probability of A intersection B over probability of only B. So this is the formula for conditional probability, that is A given that B is already there. So probability of A given that B equal to probability of A intersection B over probability of only B. And considering this concept, we will solve the practical problems. So let's get into the first problem we are going to solve under conditional probability. Our present topic is conditional probability, and under this topic we have chosen the first question from paper 9709/51 for the session May June 25. And question number 6 belongs to the mentioned topic. Let's read question number 6. A bag contains 10 marbles, of which 4 are red and 6 are blue. 4 marbles are selected from the bag at random without replacement. The random variable x denotes the number of blue marbles selected. So x indicates the number of blue marbles, not the number of red marbles. And question number A as well as B don't belong to our mentioned or discussable topics. So let us solve question number C. Question number C says, find the probability that at least 2 of the marbles chosen are blue given that at least 1 red marble and at least 1 blue marble are chosen. So this is a conditional probability. So first of all, we will find that at least 2 blue marbles as well as at least 1 and at least 1 red marble, 1 blue and 1 red marble. What does this mean? It means actually probability of at least 2 blue intersection 1 blue, at least 1 blue, not 1 blue, at least 1 blue and 1 red, 1 blue as well as 1 red. First of all, let us find this probability. So it means actually there should be no less than 2 blue marbles. Okay, so the total number of marbles chosen is 4. So out of 4, it says that there must be 2 marbles blue. So what are the possible cases? If 2 marbles are blue, so 2 blue, rest 2 will be red. Or we use addition symbol. Or there will be 3 blue marbles and 1 red marbles. I think you got my points. Look, at least there should be at least 2 blue marbles. Okay, so for 2 blue marbles, that means 2 blue marbles, or there can be 3 blue marbles. Well, now from the probability distribution table we solved and prepared in question number B, we can pick up the information. So for 2 blue, the probability of picking up 2 blue is this. Okay. So for probability of 2 blue and 2 red is 3 over 7. 3 over 7 plus plus 3 blue marbles. Probability of picking up 3 blue marble is this: 8 over 21 plus 8 over 21. So finally, if we simplify, it is going to be 17 over 21. 17 over 21. Well, then the next part of this solution, then we find the probability of picking up at least one blue and one red. Okay, so let us write probability of at least one blue and one red. One blue and one red. What are the possible cases? If there is one blue, then there will be three red, because total we have selected four marbles. So it is one blue and three red. Or there will be two blue marbles and two red marbles. Two blue and two red marbles. Or there may be three blue marbles and one red marble. So one red marbles. Now from the probability distribution table, we can find the probability for one blue marble. This is our probability. So let us write 4 over 35. 4 over 35. Then probability of picking two blue marble is 3 over 7. So let us write 3 over 7. 3 over 7. Then probability of picking three blue marble is 8 over 21. 8 over 21. If we simplify the result, it is going to be 194 over 210. So 194 over 210. 210. Now we are going to write the final step of this solution. These are the actually component of our formula. As I don't have space to write on this page, let's move on to the next page. So what was our probability? It told probability of at least two blue marbles, given that this symbol is called, given that at least one red and one blue. This conditional probability is equal to probability of at least two blue marble, given that at least one red and one blue. At least one red as well as one blue, over probability of at least one red, one blue. Actually, the formula is, let me tell you the formula on the previous page. Formula of conditional probabilities, suppose it is probability of A given that B equal to probability of A intersection B over probability of individually B. That's why first of all we have found the number probability of intersecting both the quantities. Okay, that means two blue marble as well as at least one blue and one red. Okay, then we have found if there is only one blue and one red, for which there are three possibilities. So already we have found both of the components. So first numerator is this 17 over 21 and denominator is 194 over 210. So let us substitute this value over here, equal to, the numerator is at least two blue and intersected by at least one red, one blue, was 17 over 21. 17 over 21 divided by 194 over 194 over 210. 210. Now if we simplify using our calculator, it will show 0.876. 0.876. Well, so that's the answer to the first question. Let's see the next question. So the next question has been selected from paper 9709/52 for the session May June 25, and question number 3 belongs to our discussable topic. Question says a bag contains 4 blue marbles and 12 red marbles. One marble is selected at random from the bag. If this marble is blue, it is replaced in the bag. But if it is red, it is not replaced. A second marble is now selected at random from the bag. First question says find the probability that both marbles selected are the same color. So probability of picking up same color is probability of same color. Okay, same color. So what are the possibilities of same color? There may be the first one is blue, second one is also blue. Well, our first one is red, second one is also red, because there were two marbles selected. Okay, what is the possibility of the first blue marble? There were 4 out of 16. 4 out of 16 was blue. Okay, and if it is blue, then it has been kept, replaced in the second bag. Okay, so the number of blue as well as number of total marbles will remain same. That means probability is exactly same. Let's see what happens if first one is red. So for red marble, the probability is 12 out of 16. Now if it is red, remember, if the marble was blue, then what, it was replaced in the second bag. But if it is red, there is no replacement. That means one has been, one from red as well as one from total number has decreased. So it is just 11 and total has become 15. So our probability has become, using our calculator we can write that it's 0.613. 0.613. Let's see the next one. Next question is actually on conditional probability. It says find the probability that first marble is blue given that the second marble is red. Okay, so it is, we know that probability of, what is the formula for probability? Probability of A given that B is equal to probability of A intersection B over probability of B individually. So this is the formula. That's why first we will find the probability that first one is blue intersected by the second one is red. So let us find first blue. Okay, first one is blue. First one is blue intersected by second one is red. Second one is red. Well, now let's see what are the possible cases. First one is for probability of the first one is blue. It is first one is blue and second one is red. There is only one case because there are only two marbles. So if first one is blue, out of 16 there were four. We can see here, first one was blue, second one was red. For first blue it is 4 over 16. So 4 over 16, I think I can write just beside this, into second one is red. Second one is red means first one is second one, for second one it is going to be 12 because there were 12 red marbles out of 15, sorry, out of 16, because if the blue marble is picked up then it is replaced again, so total number will remain same, but red, there were 12 red marbles, that's why it will remain as it is. So finally we are going to see that our probability is 48 over 256. 48 over 256. Well, then the second component of our probability, that the second one is red. Okay, for second one is red, probability of second red, second one is red. So for being the second one red, there are two possible cases, equal to, it may be first one is blue, second one is red, or first one is red, second one is also red, isn't it? So if first one is blue, second one is red, it's already we have found the probability is 48 over 256. Or individually if we write, it is 4 over 16 because there were 4 blue marbles, and second one is red as it has been replaced, so total number is same and number of red marble is 12. Or if first one is red, it was 12 over 16, 12 over 16, and remember whenever a red marble is picked up then there is no replacement, so both of them has been decreased, 11 over 16, sorry 15, 11 over 15. So finally our result is going to be, using our calculator, it is going to be 177 over 240. So the probability of a second red is 177 over 240. Now we can write the probability of our question was what? Probability of first marble blue given that second marble red. So let me write over here probability of first blue given that second one is red, equal to, we know the formula is probability of first blue intersection second red over probability of the second one to be red, probability of second one red. So already we have found the probabilities individually. Let us substitute the values. For first one blue intersected by second red, probability is 48 over 256. So we will just write here 48 over 256. 48 over 256 divided by, what is the probability of second red? Probability of second red is 177 over 240. So 177 over 240. Now if we calculate this quantity using our calculator, we will get 0.254. 0.254 is our conditional probability or answer to this question. 2, 5 and 4. So our answer to the question is 0.254. I think you have understood the point. Our fundamental formula is this, that probability of A given that B equal to probability of A intersection B over probability of B. The next question has been selected from paper 9709/53 for the session May June 25, and question number 5 is to be solved. It says bag A contains 6 red marbles, 5 blue marbles, and 1 green marble. So total number of marbles is 6, 5, 11, so 12. Bag B contains 5 red marbles and 3 blue marbles. So total number of marbles is 8. A marble is chosen at random from bag A and placed in B. So from A, the marble has been placed in B. A marble is now chosen at random from bag B. Draw a tree diagram to represent this information, giving the probability on each branch. Since question number A doesn't belong to our discussable topic, let's see B. B is on the next page. B says, find the probability that both marbles chosen are same color, not this one even. So question number C is the conditional probability. Find the probability that the marble chosen from bag A is blue, given that the marble chosen from bag B is also blue. So we will write here first probability of first one is blue, bag A. Okay, from bag A it should be blue. Intersection bag B is also blue. So in bag A there were 5 blue marbles. So we will have to write 5 over 12. Okay. And in bag B, look at this. This marble has been kept in the second bag, bag B. So the number of marbles in bag B, it will be 9, because 8 plus 1 is equal to 9. And there were again blue marbles. There were 3 blue marbles. Now it will be 4 blue marbles. Let me show you from that page. Look at this here. In bag A there were how many blue marbles? 5 blue marbles. Okay, so we have written 5 out of 12. Total there are 12 marbles. Then if this blue marble is kept in the second bag, then it will be 4 blue marbles out of what? 3 plus 5, 8 plus 1, 9. So out of 9, now number of blue marbles is 4. So that's why we have written 5 out of 12 plus 3 into 3 out of 9, because number of marbles in the second bag will increase, number of blue marble will increase, at the same time number of total marble will also increase. That's why it's 4 over 9. So using our calculator we will get that it is going to be 20 over 1, not 20 over 108, 20 over 108. Okay, then the next component of our probability is, given that the marble chosen from bag B is blue. So this is only about bag B. So let us write probability of bag B blue. Okay. And for bag B, if it is blue, what about bag A? There is no clear instruction about bag A, so there are the possible cases. If second one is blue, then maybe first one may also be blue. Second one is blue. There may be first one is red, second one is blue, because our condition is about second marble, not about the first marble. And out of two, since there were 2 marbles picked up, so first one may be green and second one is blue. So what are the probabilities? If we write the probabilities, first one blue, second one is also blue, already we have written it is 20 over, means 5 over 12 into 4 over 9, plus first one is red. How many red marbles were there? Surely 7 red marbles. So, sorry, not 7, it will be 6, because 5, 6, 1, 1 was green. So it will be 6 over 12. Now if second one is blue, second time there were 3 blue marbles. Okay, as one marble has been given, so blue marble will not increase because first one was red, but total number will be increased. Total number was 8, now it is 9. Okay, there was only one green marble, so 1 out of 12 from the first bag. And this marble has been kept in the second bag, so total number is 9. But second one, I mean blue marble, there were 3 blue marbles, still there are 3 blue marbles. So if we use our calculator, it will show that our probability is going to be 41 over 108. 41 over 108. Now we are going to write the final part of the answer, which is probability of the condition. Question is probability of from bag A it should be blue, given that from bag B it is also blue, over equal to, if we apply the formula, it is bag A blue intersection bag B also gives blue marble, over probability of bag B blue. Okay, so the answer should be, already we have found the quantities. The first probability, when bag A, from bag A blue marble is chosen and from bag B also blue marble is chosen, our probability is 20 over 108. So we will write 20 over 108. And if the condition is only the second marble should be blue and there is no question about the first marble, the probability is going to be 41 over 108. So finally, if we divide 20 by 41, it is going to be 0.488. 0.488. So that is what the final answer to this question is. Let's select the next question. The next question belongs to paper 9709/55 for the session May June 25, and we are solving question number 4. Students applying to Drydale College take an entrance test. A student is either accepted or rejected or required to take another test with probabilities 0.3, 0.2, and 0.5 respectively. When a student takes a second test, the outcomes and probabilities are exactly the same as for the first test. A student who has to take a third test is accepted with probability 0.25 or rejected with probability 0.75. Draw a tree diagram to illustrate this information showing all the probabilities. First question belongs to a tree diagram, which doesn't belong to our present topic, but the information may be required for our solution, so we have left it solved here. So let's see question number C. We are going to solve question number C. Question number C says, find the probability that a randomly chosen student who applies to Drydale College takes at least 2 tests, given that the student is accepted. So after second test he was accepted. That means first time he was given a chance to take part in the second test, and second time also he has been given a chance to sit again. Then finally in the third chance he was accepted. So first of all, we will have to write probability of second test was done, and then he was accepted. He was finally accepted. Okay. So if second time he takes the chance, what are the probability? That is, he might be he, what was the cases? First time he must take the second chance. So first chance was given and then he was accepted. Or second time he was, first he was given a chance, again he took the chance, and then he was accepted. So these are the possible cases for a student to be accepted. Okay. The question is at least two tests. Okay. At least two tests. So it should not be second test. It should be at least two tests. So let me rectify this. Yes, this is the actual scenario. That means at least he was given two chances and then he was accepted. That means it might happen that first time he took a test, then in the second time he was accepted. Because look at this, at least two tests means initially for the first case, I mean first time he was not accepted. Okay. So at least two tests means there he might be given one chance or he might be given two chances. So one chance means actually T. That means for second test. Or if he has accepted all the opportunities, that means first time he failed, means he was given a chance to take test again, then he was given a chance to take part for the test, and then finally he was accepted. So what are the possible cases if first one is T and A? From the previous page we can insert the information. Yes. First one is T. For first T it is zero point 0.5, and then if he is accepted it is zero point 0.3. So 0.5 into 0.3. For the second one, first time he was given a chance, again he couldn't qualify, then he was given another chance, then he qualified. So what are the probabilities? For the first case, it was T into A. Okay, zero point 0.5 into 0.3. For the second case, it is first he was given a chance, 0.5, again he couldn't qualify, so he was given the second chance with 0.5, then finally he was accepted, he qualified with 0.25 as probability. So let us write all of these probabilities. It is going to be for the first one, first T was zero point 0.5, and if he is accepted, then it is zero point 0.3 for the second test. Then for the first chance he was given a probability is 0 0.5, and for the second chance also probability is 0 0.5, and finally for acceptance the probability was 0.25. Okay. So what is it going to be if we sum up? It is going to be 0.2125. Well, now second part of the solution, that probability of the student was accepted. Okay, probability of acceptability. So there are three possible cases actually. He might be accepted at the first test, or he failed in the first test and accepted in the second chance, or he might fail in the first test as well as second test, but finally in the third chance he got succeeded. So these are the probabilities. Now we are going to find the probabilities from the tree diagram. If he succeeds in the first test, if the student succeeds in the first test it is first chance 0.3. Okay, if he takes second opportunity, so for T, for failure, it is zero point 0.5, and then he might be accepted, so it is 0.5 into 0.3. Okay, again the third case is first time he was given opportunity, again second time also he has to take a chance, then finally he was accepted, so it is zero point 0.5 into 0.5 into 0.25. So these are the possible cases. First 0.3, then 0.5 into 0.3. So first one was zero point 0.3 for succeeding in the first chance, zero point 0.3. Or he might be given the chance to take part in the second chance, then acceptability is zero point 0.3. Or he failed in the first test as well as second time, but finally he succeeded, whose probability is 0.25. Then after simplification we will get that 0.5125 is the probability. Now we will write the final part of the solution. What is the final part of the solution? That probability of at least two tests given that accepted. So we will write here probability of two tests given that the student is accepted equal to probability of two test intersection accepted over probability of acceptability. And we have already found these components, so we can substitute the values. So let us substitute the values. First probability was this 0.2125, which will be divided by 0.5125 equal to 0.2125 over 0.5125 and using our calculator we can find the answer to this conditional probability is 0.415. 0.415. Well, then the immediate next question, though this doesn't belong to our today's topic, yet let us solve this. The friends three friends apply to Drydale College. Find the probability that all three are rejected. Since the total number of student or total number of experiment is given, that three friends, so it actually belongs to binomial distribution. In the binomial distribution we didn't solve this, that's why let us solve right now. And the parameters for binomial distribution is x belongs to binomial distribution, and parameters are total numbers is 3 and individual probability. So let us see what is the individual probability for one student, not all three students. So for one student, for being rejection, what may be the possibilities? Let us find this. The probability of rejection, okay, for one student, he might be rejected in the first chance, or he was given second chance, that means T, then he was rejected, or he took the third chance, that means first time he failed, second time he failed, third time he was rejected. So what are the probabilities for first rejection? From the previous page, for first rejection the probability is 0.2. For the second rejection, it will be 0.5 into zero point 0.2. For third rejection, it will be zero point 0.5 into zero point 0.5 into 0.75. So these are the probabilities. Let us substitute these information. If we substitute this information, for first rejection, probability of rejection is 0.415. For first rejection probability is 0.2, or first chance for second test probability is 0.5, and for rejection probability is 0.2. And if he takes two chances, so 0.5 for first chance, and probability of second chance is also 0.5, then if he is rejected, then probability is 0.75. 0.75. So what will be the probability of a student who may be rejected is equal to, if we use our calculator, it is going to be 0.4875. 0.4875. 4875. Well, so our parameter is, this is our parameter 0.44. Remember, parameter is individual probability of one unit or each experiment. 0.4875. As this is binomial distribution, how to write binomial distribution? Probability of all three. Okay, x equal to 3. That means all three. Probability of x equal to 3 means all three are rejected, is equal to 3 out of 3. 3 choose 3, you know the combination formula. Out of 3, 3 out of 3. 3 out of 3 have been failed, and our probability of rejection is 0.4875. If probability of rejection is 0.4875, that means 3, all 3, and probability of acceptance will be 1 minus this, which is 0.5125. 0.5125, and no one was rejected, I mean accepted. So finally 3 choose 3 is actually 1, and 0.51250 is also 1. That means our probability is 0.4875 3 times. Okay, so finally our probability is going to be equal to 0.116. 0.116. 0.116 is the probability of 3 students being rejected. So that's all about this topic. Let's see the next topic.